The long-term goal is to go to Mars. And so only 24 humans have ever gone into what we call deep space, and that's beyond the magnetosphere. And so there's this magnetic field that surrounds the Earth and helps deflect a lot of the very damaging space radiation. And so the International Space Station is within that magnetosphere, so that helps protect those astronauts a lot. Those 24 Apollo astronauts that went to the moon are the only humans to have traveled outside the magnetosphere. And of course, they had very short duration missions. And the question is, how is long-term exposure to that deep space radiation, which is more biologically damaging than any radiation that we experience here on Earth, what might be the long-term consequences for that? So now with space agencies planning on going to the moon, most seeing that as a jumping off point to eventually go to Mars, the issue of long-term health consequences due to deep space radiation is very important. So deep space radiation is a very unique type of radiation. We don't really experience it here on Earth at all. It's more biologically damaging to tissue. It can cause complex breaks in the DNA that's very hard for cells in the body to repair. What are the long-term consequences of radiation? Does it differ in males and females? And are there countermeasures that we can use to mitigate those effects to make deep space travel more safe for humans? This is the beginning. If you think hundreds of years from now, when we hope that deep space travel would be routine, they will look back at this point in time and say, this is when human exploration into deep space started. And to be able to be part of that, a small part, to be a part of that is really exciting for me. And it gives me a lot of fulfillment and satisfaction in what I'm doing professionally, to know that it could be something that has really big long-term consequences to exploration of the universe.